we are starting with the topical past paper questions of CRV, continuous random variable. What exactly is a CRV? A CRV is a function. This function, it's called a probability distribution function, also known as the probability density function. A function that gives us velocity over a range of values. Now, for example, if I look at this question, the average speed of bus X kilometers per hour on a certain journey is a CRV with a probability density function given by. If X is K over X squared, X lies between 20 and 28, 0 otherwise. This second statement will always be given, that is 0 otherwise. That means this function is only valid for this range. For any other value, this function has no significance whatsoever. So now let's start with the first part. In the first part, if I integrate k 1 over x squared between the limits 20 and 28, that is the concept of area under the graph, and that should equal to the total probability, which is 1. That is the first step that you should write. Second step, write it as an index form, write in the form of indices. So this is x raised to power of minus 2. The limits are still intact because you have not integrated it as yet. Do not remove the integral sign. Now let's integrate. When you integrate, k remains as it is. X minus 2 plus 1, minus 2 plus 1. Between the limits 20 and 28 equals to 1. So therefore, this becomes k. The denominator is minus 1. This denominator is minus 1. So I'll write this minus 1 on the outside. And this becomes 1 over x between 20 and 28 equals to 1. Remove the negative sign by flipping the limits. So therefore, this is positive k. 1 over x, 28 goes down, 20 goes up equals to 1. My generous advice to you, sincere advice to you is that do not skip a single step. Every step counts a lot. The first step was writing the original function as it is. Second step, writing in the proper index form in terms of indices, because integration won't be possible without it. Third step is integration. Fourth step is taking the minus on the outside. Fifth step, removing that minus sign, and to compensate for that, what you are doing is that you are switching the limits. Upper becomes lower, lower becomes upper. Now, when everything is set, everything is crystal clear, now write down k on the outside, 1 over 20 minus 1 over 28 equals to 1. Now, once you have done this, what is left? K remains as it is. Let me go to the next page. It's getting clustered over here. So on the next page, what you do is that k as it is, 20 and 28, that is the product, and 28 minus 20, that is equals to 1. Therefore, k is 20 into 28 divided by 8. And then when you simplify, 4 2s are, 4 5s are, and 2 1s are, 2 14s are, 5 into 14 is 70. So you obtain k with basic knowledge of math without using a calculator. That was the first part. Now let's move to the second part. The second part is find expectation of x. What is the formula for expectation of x? Expectation of x is integrating between the full limits, which is 20 and 28. There is an x on the outside. There is k over x squared. I can substitute in the value of k later on. That's not a big deal. First, simplify. So I'll take k on the outside. This is 20, this is 28, this is 1 over x dx. Should I write this thing in the index form? There is no need. The reason being, we know that derivative of ln x is 1 over x. In other words, integral of 1 over x dx is equals to ln x plus a constant of integration c. So therefore, this is k as it is. This is ln x between the limits 20 and 28. K is 70. This is ln 28 minus ln 20. Of course, you can use a calculator. So therefore, this is 70, whatever the calculator says. Let's see it from the mark scheme. That is, this comes out to be 23.6, 23.5, 70 ln 1.4, 70 ln 7 over 5. That means if I use the knowledge of logs, so I can simplify and write this thing as ln 28 over 20. Now 28 over 20, that is 7, 4 sevens are, 4 fives are. So this is 7 ln 4 sevens are, 4 fives are. You can write it like this. You can write in terms of decimals. And then, of course, you can use a calculator and you can simplify. That comes out to be 23.6, correct to 3 significant figures. So that is the working behind the expectation. Now, let's move to the third part. Find the probability x is lesser than expectation of x. Now, over here, let me paste it over here and once more. Probability x is lesser than expectation of x. What is expectation of x? That comes out to be 23.6. Whatever was the unrounded value in 4 significant figures, officially you should be using that. Probability x lesser than 23.6. That means 23.6 becomes the upper limit for this working. And what is the lower limit? The lower limit is 20. Therefore, k is on the outside, that is 70. 1 over x squared, that was the original fraction. And now the upper limit is 23.6, lower limit is 20. 70 as it is. Do not integrate unless you have set up everything very, very carefully. This is 20, this is 23.6. This is 70 as it is. X minus 2 plus 1, minus 2 plus 1. Between 20 and 23.6. If someone wants to use the previous working from the first part, they are most welcome to do so. We know that this is k minus and 1 over x between the limits. So I could have reached that point and then carried on, but I feel comfortable in showing all the steps, and it hardly took maybe like 20 seconds. So therefore, this is minus 70, 1 over x, 20 is down still, 23.6 is up, 70 becomes positive, and limits, and 20 goes up, 23.6 goes down, 1 over x, and now you use a calculator, and let's see what answer do we get. We get the answer 0.528, except, look at the different possibilities. If someone has used 23.6, except 0.534. If someone has used 23.5, except 0.521. So let's just write down 0.528, whatever the answer is. Of course, when the examiner says except, that means those people did not take care of the accuracy. So it might have been 23.57, okay? And the exact answer that's coming out is 0.528. So 0.528 or 52.8%. That is the probability of the variable x lesser than the mean. Now let's come to the fourth part. The fourth part is the conceptual part. Before that, let's understand one thing for sure. We have, of course, gone over it again and again in O-level math and then in CRV, and of course in S1. What is Q1? Lower quartile. What is Q2? median. What is Q3? Upper quartile. We all are aware of it. For example, if I say, write down the following probabilities. Probability X is less than Q1, probability X is less than Q2, probability X is less than Q3. That means there is nothing to calculate because they are so obvious. Lower quartile is that particular value in any distribution below which 25% of the distribution lies. Median is that particular value below which 50% of the distribution lies. We won't talk about greater, we won't talk about more, we would simply talk about lesser. Lower quartile, less is 25%. Median, less is 50%. Upper quartile, less is 75%. Now, what exactly is the examiner asking? The examiner is asking, hence determine whether the mean is greater than or lesser than median. Now, over here, you are not supposed to calculate the median. You want to, if you can. Of course, I can. I can say probability X lesser than Q2 is 0.50. Therefore, Q2 becomes the upper quartile. Lower quartile is how much? 20. K is 70. This is X minus 2 dx equals 2.5. And then if I calculate, I'll find a value of Q2. And that is so obvious that you have the mean as 50, how much? 52.8, I think. The mean is 23.6. The mean is 23.6. And the median is some value. And of course, you can say which is greater, which is lesser. But this will take some time. Maybe you come across a question in which the calculation of median requires something very extraordinary. Maybe there is a possibility. That means there has to be some other solution possible. Mean is greater or lesser than median. What we should do is to draw a thick, fat number line. This is the median. And median is the value. Yeah, let me first put in the mean. Somewhere here is the mean. And we know that probability X lesser than mean, we calculated it. That was something more than 50%, which is how much? 52.8%. So that is 52.8%. And we know for sure that probability X lesser than median, Q2 is the median, is 50%. So on this number line, we know that if I take this value, this is 20. If I take this value, this is 28. What is the probability X is less than 20? There is nothing below 20. That is 0%. What is the probability X is lesser than 28? Of course, we would stop at 20. So that is 100%. Agreed? Now, let's remove this. We know that if I draw a number line from expectation till 20, if I draw this number line from here till here, that percentage is technically the length of the number line. Agreed? If I want to draw for 50%, of course, I would start from 20, go backwards, and this line should be shorter. That means if this is 50%, of course, not drawn to scale, my median value should be here. Understand this. Probability X less than expectation of X is approximately 53%. Probability X lesser than Q2 is 50%. The number line of Q2 is shorter, whatever the lower limit is. We are going back of the lower limit. That means from our observation, we can comfortably say that in this scenario, expectation is greater than median or median is lesser than expectation. go through it again. One option is calculate the median. That is for simple-minded people. Provided that integration is possible, that solution, that working for median is possible. Go ahead, calculate the median, and then state the obvious. Okay? For the intelligent people, this is the method. Probability, and this is what the examiner is asking you to do. Probability x less than expectation of x is 52.8%. So you draw a number line. Probability x less than Q2, that is a universal truth. We call it the median. Probability x less than expectation of x, probability x less than median is 50%. So now this value is shorter. So therefore, from the number line, I can see that expectation is greater than median. Now let's use this question and let's add some more flavor to it. For example, a scenario in which probability x lesser than expectation of x comes out to be 50%. And we know for a fact probability x lesser than median is also 50%. I think this is very, very obvious. What is the conclusion? The conclusion is, without drawing any number line, you would say expectation is the same thing as median. Agreed? Because the length of both the lines is exactly the same. If you want me to draw the number line, I can of course draw it. This is expectation of x, this is 20, lower limit, this is upper limit. No need to label it as such. This is A and B. Somewhere here is expectation of x, and this probability is 50%. The same length would be for the number line for median. So up till here, this is also the same length, 50%, and this is Q2. What is the conclusion? Expectation is equals to Q2. What do you think is the third scenario? The third scenario is probability x lesser than expectation of x is 46.1%. We know probability x less than Q2 is 50%. Thus, median probability is fixed, it's constant. So now if I draw a number line, this is A, this is B, upper limit, lower limit, whatever they are, less than Q2, somewhere here, yeah, should I draw first expectation of x? Somewhere here is expectation of x, let me brighten up a bit, is 46% approximately. Probability x lesser than median, that's a universal truth, that is 50%. So this is Q2, it's not drawn to scale. This is 50%, definitely it's greater than the orange line. Therefore, what's the conclusion? Expectation is lesser than median, or median is greater than expectation of x. Now let's go through each part very, very carefully from the beginning. First of all, what is it asking for? It's asking for the value of k. Take care of all the necessary steps that I've asked you to do so. You find the value of k, without using a calculator. I'm obsessed with that. Is 70. Second part, expectation of x, multiply the function by x, integrate it with the full limits, and you find expectation of x, that is 23.6. The answer definitely would have come out as inexact. So work in 4SF, use 4SF for the other part. For this particular part, give the answer as 3SF. Probability x is lesser than expectation of x. Expectation of x, 23.6. The unrounded value should be used, is the upper limit. Lower limit of this function is 20. Integrate, and the answer we obtain is approximately 53%. Then, stating the universal truth. Focus on the median right now. Probability x lesser than Q2 is 50%. One approach is that find the median itself and then compare. That's not a big deal. Second approach, draw a number line. probability x less than expectation of x is 53%. I'm saying it approximately. X lesser than Q2 is 50%. So therefore, the expectation line is bigger. Of course, you can generalize it also. Right now, I'm focusing on the number line. Once you have done 3 examples, you can generalize. I'll tell you how so. The expectation line is bigger than the median line. So expectation is greater. Expectation line and median line is the same. Therefore, expectation probability lesser, median probability lesser is the same. Therefore, expectation is equals to Q2. Expectation probability is 46%. Median probability is 50%. Therefore, this time the expectation line is shorter. So therefore, expectation is lesser than median. If you want me to summarize it, this is how I'll summarize. I'll write it like this. Probability x lesser than expectation of x is a value, this thing, something percent. Probability x lesser than Q2 will always be 50%. 3 possibilities are there. Let me write this thing in percentage. So everything is in percentage. Three scenarios are possible. This percentage is greater. This percentage is equal to. This percentage is lesser. If this percentage is greater than 50%, that means the expectation line is longer. So therefore, expectation is greater than median. Perfect. That was the first example. Second example, if this percentage is equal to 50%, what's the conclusion? Expectation of x is equals to Q2. If this percentage is lesser than 50%, what's the conclusion? Expectation of x is equals to, is lesser than Q2. Done. Made it very, very easy for you people. Okay? So you don't even have to think. Now let's look at what the examiner has to say. Greater probability in part 3 is greater than 0.5. Now the examiner is not very keen on explaining every single step. The examiner, his prime responsibility is writing down the answer and then giving the reason that it's 1 mark or 2 mark and nothing more than that. The mark scheme is primarily for the teachers and not for the students. So it's the teacher's responsibility and how the teacher can explain it in a simple sense, which I have done so. Now, this question is done. Let's move on. Something like, for example, question number 7. Question number 7, it says, the random variable x denotes the number of hours of cloud cover per day. At a weather forecasting station, the PDF is given by such and such. This is the PDF that we are working with. And then it says, show that k is 2016. That's straightforward. I'm simply writing it down. 1 over k is on the outside. Limits 0 and 24. X minus 18 whole square dx equals to 1. This is a simple application of chain rule of P1. Second part, on how many days in a year of 365 days, because there could be a leap year like 2020, which has 366 days. On how many days in a year of 365 days can the center expect to have less than 2 hours of cloud cover? Expect. This is the keyword, expect. Second part, less than 2 hours. So probability x is lesser than 2, and therefore this is 1 over 2016, and therefore the lower limit is 0, the upper limit is 2, where x is the number of hours. It's for the whole day, that's why 24. And therefore this is x minus 18 whole square dx. And then you integrate and you get a probability which is something percent. What are they asking us? They are asking expected value. We know that expectation of x is NP. Because why does it become a binomial question? Because x follows a binomial distribution. We are talking about 365 days, and the probability of success is what you have calculated from CRB. So you obtain the probability from CRB and you create a binomial. Just like in S1, you did questions in which you were talking about the probability that find the probability that the weight of an apple is lesser than 210 grams. And then you calculate the probability. If you have forgotten that, let me recap it for you. For example, x follows a binomial distribution 200, 100. Find the probability that the weight of an apple is greater than 210 grams. Probability z is greater than 210 minus 200 divided by square root of 100, which is 10. Probability z is greater than 1. 1 minus pi of 1. 1 minus 0.8413 from the table, which comes out to be 0.1587. This is the probability that the weight of an apple in grams is more than 210 grams. If I say 1,000 apples are taken, find the expected number of apples weighing more than 210 grams. So this is the probability that you have obtained, more than 210. So you would write x follows a binomial distribution 1000, 0.1587. Expected value, that is NP, that is 1000 into 0.1587, which is 158.7. And the examiner is happy with rounding down or rounding up because it's about an apple. You can take a chunk of it and give it to someone else. You have to give it as a whole. So 158 is also an acceptable answer. 159 is also acceptable. Coming back to this, x follows the binomial distribution. We are talking about 365 days in a year. Probability of success is that particular percentage. Expectation of x is NP. So therefore, this is the expectation. And then what do? You say expectation is 365 multiplied whatever this probability is down, stage is up. Okay, G. So this thing is done now. Let's move on. Something with an unknown. For example, we have this question. Let me look for the nice ones. Let me first focus on 10. Let me do it in half and half. Okay, add some more. All these are good questions. Okay, we are starting with this question number 10, and let me also open up the mark scheme for quick reference. And that was question number 10 as what we are focusing on. Okay. At a town center car park, it's a mall, shopping center. The length of stay in hours is denoted by the random variable x, which has a PDF given by such and such. Length of stay in hours, I'm underlining it. PDF 129. First question is about common sense. Interpret the inequality in the definition of fx in the context of this question. This is a car park, agreed. Now this car park, x is number of hours, and 129 means 129 hours. What does it mean? That means in this particular car park, the minimum amount that the car will stay is 1, and the maximum it would stay is 9 hours. Okay, so that's what 129 means. Or we can say the car park is open for a maximum of 9 hours. That is a far-fetched conclusion. Better is that in this car park, the number of hours for which a car stays lies between 1 and 9, and later on this will be connected with the charges. That means the minimum charge would be for 1 hour and the maximum charge would be for 9 hours, something like this. Show that k is equals to 3/4. That is straightforward. Simply writing it down. This is k, x minus 3/2 dx equals to 1. What are the limits? The limits, lower limit is 1, upper limit is 9. And then you find the value of k as 3/4. Third part, calculate the mean length of stay, the average expectation of x, that is x multiplied by fx. So put the integral sign on the outside. This is 1, this is 9, this is x minus 3/2 dx. What is the power of x? 1. So therefore this becomes 129 x minus half dx. Now integrate it. Don't forget the k, I forgot it. This is k, leave it as k. And then if I add one more step, this is k as it is. And therefore after integration, minus half. So this is x minus half plus 1, minus half plus 1, between the limit 1 and 9. Let k remain as it is. Minus half plus 1 is half. Division by half is multiplication by 2. And this is square root of x between 1 and 9. This is 2k root 9 minus root 1. It's a nice calculation. This is 2k 3 minus 1. This is 2k into 2. This is 4k. But what is k? K is 3/4. Therefore, you get 3. That is hours. That means the mean length of stay at this car park is 3 hours. Straightforward calculation. Now it says the charge for a length of stay of x hours is this much. This is not a PDF. The charge for a length of stay of x hours is this much. Find the length of stay for the charge to be at least 0.75. This is a simple mathematical calculation. You want the length of stay, that is x. So you are calculating for x. Find x. What is the condition for finding x? That is, the charge should be at least $0.75. What is the equation for charge? 1 minus e raised to power of minus x is greater than or equal to 0.75. Negative e minus x is greater than or equal to 0.75 minus 1, which is negative 0.25. Take care of the plus minus sign. Remove the minus and the minus. What do you get? E minus x is lesser than or equal to 0.25. Now it's ready for ln to be used. Ln e raised to power of minus x is lesser than or equal to ln 0.25 minus x ln e is lesser than or equal to ln 0.25 minus x ln e is 1 is lesser than or equal to something negative. What is ln of 0.25? Let me have a look. That comes out to be 1.39. So this is negative 1.39. Therefore, what's the answer? X is greater than or equal to 1.39 because the inequality flips. This was the first flip. This was the second flip. Find the length of stay. The length of stay is at least 1.39 hours. For the charge should be greater than 0.75. So basically, you can write the answer to be 1.39 hours. If a car is staying there for 1.4 hours approximately, then the minimum charge would be 0.75. Of course, if he increases the number of hours, the charge would go up. Now, here comes the last part, which people find most tricky. Find the probability of the charge being at least 0.75. What do you think people make a mistake in this particular part? What people do is that they try to plug in 0.75 in place of x, which is all wrong. It's wrong for two reasons. Number one, 0.75 is dollars, whereas x is hours. How can you plug it in? Second thing, if you even want to think pragmatically, the minimum value of x is 1, so 0.75 won't fit in any way. Okay? That's for practical purposes. But the reality is 0.75 is dollars. How can you plug in dollars in place of hours? But you did the second part, remember? We know that $0.75 correspond to 1.39 hours. That means the charge to be at least $0.75 means the length of stay to be at least 1.39 hours. Therefore, the final step is probability x is greater than or equal to 1.39. Integrate the function 1.39. Upper limit is how much? 9. Function, original function is which one? K is 3/4 and x raised to power of minus 3/2. K is 3/4. This is x raised to power of minus 3/2 dx. Integrate this function with the given limit, and this probability is what you are looking for. This is the probability. You can write it in percentage or you can write it in decimals. Let's look at the answer. Probability x is greater than 1.386. Definitely you should use the unrounded value. Okay? This is unrounded value. And that is what they have done. So therefore, what is the probability that the charge is at least $0.75? 77.4% is the probability of the charge to be at least $0.75. Have a look at it again. The first part, that was about finding K. Second part, first part was the interpretation of x between 1 and 9. Second part was finding K. Third part was expectation. The first three parts, the first 6 marks were easy. Then it's asking the charge for the length of stay. This part had nothing to do whatsoever with the PDA. It was just an equation given. Make it greater than or equal to 0.75. You have studied P3, you have studied it very well, and of course you would be studying it also more and more for the past papers. So now greater than or equal to 0.75, take care of the flipping. There were two flips, one because of the initial minus sign on both sides, second flip because x had a negative sign and the log of a number lesser than 1 is also negative. So double flip, you get x is greater than or equal to 1.39 hours, which you should write as 1.386. That is an exact answer. And for this part, 1.39, that is 3SF for this particular part. Then it says, find the probability of the charge being at least 0.75. Who will give you the probability? The PDF, probability density function. $0.75 cannot be substituted in the original one because 0.75 is in dollars, X is in Rs. But we know from fourth part that $0.75 is equivalent to 1.39 hours. At least $0.75 means at least 1.39 hours. Therefore, the length of stay should be greater than or equal to 1.386. Okay? Use unrounded value. And then you get a percentage, which in this case came out to be 77.4%. Okay, so far so good. Let's move on. Question number 9. The random variable x has a PDF given by fx is 4x power k. X lies between 0 and 1, where k is a positive constant. Show that k is equals to 3. Now, unfortunately, for some reason, a lot of people get this part wrong. I don't know what's the reason. 4 is outside, x power k dx between the limit 0 and 1 equals to 1. 4 as it is. First integrate x k plus 1 over k plus 1. That is also one thing that people, they don't integrate and somehow they plug in the value of 1 in place of x. Even stranger, some people, they plug in the value of 1 in place of k. I don't know how. So this is 4 over k plus 1. X raised to power of k plus 1 between the limit 0 and 1 equals to 1. It's a nice, cute question. This is 4 over k plus 1. 1 raised to power of k plus 1 minus 0 raised to power of k plus 1. This is where it tests your faith about math. 1 raised to any power would remain as 1. 0 raised to any power would remain as 0. So therefore, you are left with 4 over k plus 1. 1 minus 0 is equals to 1. Therefore, 4 is equals to 1 times k plus 1. This is simply 1. Therefore, 4 is equals to k plus 1. Eventually, k comes out to be 3. Okay. Second part, show that mean of x is 0.8. So therefore, first write the function fx 4x cubed between the limits 0 and 1. Mean of x is 0.8. Expectation of x, we have to show this. That is 4x into 4x cubed. That's how you should write it. And of course, you can simplify it later. Between 0 and 1, 4 on the outside, x4 dx. That's 4 x5 over 5 between the limit 0 and 1. That is 4/5 x power 5 between 0 and 1. That's 4/5 1 to the power 5 minus 0 to the power 5, which comes out to be 4/5 or 0.8. Find the variance of x. Expectation of x square is 0 till 1. X square into 4x cube dx. 4 outside, 0 till 1. x5 dx. 4 outside, x6 over 6 between limit 0 and 1. 4 over 6 is 2/3. 1 to the power 6 minus 0 power 6. That comes out to be 2/3. Last, variance of x. That is expectation of x square minus square of expectation of x. That is equal to expectation of x is 0.8 and this is 2/3. So 2/3 minus 4/5 square. That is 2/3 minus 16 over 25. That is 3 and 25. 25 into 2 is 50. 3 into 16 is 48. That comes out to be 2 over 75. Or, of course, you can write the answer in decimals. That is about variance of x. Then it's asking upper quartile. Then it's asking interquartile. Okay. So now, for finding, let's find the upper quartile and the lower quartile one by one. Probability x less than q1 is 0.7 or q1 is 0.25. Therefore, what is the function? The function is 4x cubed, correct? Function is 4x cubed. This is 4. This is x cubed. This is dx. This is 0.25. Lower limit is 0. Upper limit is q1. 4 as it is. x4 over 4. This is 0. This is q1. This is equal to 0.25. The good thing is 4 cancel. q1 raised to power of 4 minus 0 power 4 is equals to 0.25. Therefore, q1 is 0.25 raised to power of 1/4. And of course, you can use a calculator. Probability x less than q3 is 0.75. Probability x is less than q3, that is 4, 0 to 1, x 0 till q3. And this is x cube dx is equals to 0.75. 4 as it is. x4 over 4 between the limit 0 and q3 is equals to 0.75. This is q3 power 4 minus 0 power 4 is 0.75. Therefore, q3 is 0.75 raised to power of 1/4. Of course, we'll only take the positive value. Okay? A lot of people won't even think. When you take the even root, a positive and a negative value occurs. Why are we taking only the positive value? We take q1 to be positive only. We take q3 to be positive only. Why? Because the function ranges between 0 and 1. There is no possibility for a negative value. Maybe in some other question, we have seen such questions. It's going from 0 till infinity. It's going from -2 to 2. In such a scenario, if a negative value exists, go ahead and take the negative value. So now this is the working.